The next concept we are going to discuss is Faraday's law of electromagnetic induction. According to Faraday's law of electromagnetic induction, whenever there is a change in magnetic flux linked with the circuit, there is a production of EMF in the circuit. The magnitude of the induced EMF is equal to the rate of change of magnetic flux linked with the coil. That is, induced EMF E is equal to rate of change of magnetic flux linked with the coil. If it has n turns, then induced EMF E becomes d phi by dt. But it only tells you about the magnitude of the induced EMF. Therefore, I write mods here to indicate that this does not give you the direction of the induced EMF. Let us see the next question, which depends on Faraday's law of electromagnetic induction. The magnitude of the induced EMF in a coil of 20 turns is 1.5 volt. If the change in magnetic flux happens in 2 milliseconds, the change in magnetic flux is. The given quantities are induced EMF is given, that is 1.5 volt. The time is, a number of turns is given, that is 20. The time taken for the change in magnetic flux is given, that is 2 milliseconds, that is 2 into 10 power minus 3 seconds. I have to find the change in magnetic flux delta phi b, that is question mark. By Faraday's law, magnitude of the induced EMF is equal to number of turns into change in magnetic flux divided by time taken. Therefore, change in magnetic flux becomes EMF into time taken divided by number of turns, which is equal to EMF is 1.5 into time taken is 2 into 10 power minus 3 divided by number of turns is 20. This goes 10 times. Therefore, 1.5 divided by 10, which is 0.15 into 10 power minus 3 Weber, which is equal to 0.15 milliweber. Therefore, the answer is B, 0.15 milliwebers. In the last problem, we calculate the average EMF induced in a circuit using Faraday's law. But if you are given with some time dependent function for magnetic flux, how do you find the instantaneous EMF? Let us see the next question. The magnetic flux linked with the circuit is given by phi b is equal to tq plus 3t minus 7. If you plot a graph of time along x axis and induced EMF along the y axis, graph is a straight line through the origin, straight line not through the origin, parabola through the origin, parabola not through the origin. Let us see what is the given function, what the given function is. The given function is phi b is equal to tq plus 3t minus 7. You have to find the EMF. EMF is equal to minus d phi b divided by dt. This is Faraday's law with Lenz's correction, which is equal to d by dt of t cube plus 3t minus 7, which is equal to minus 3t square plus 3t. That is equal to minus 3t square minus 3t. You are plotting this along the y axis, time along the x axis. This is the form y is equal to ax square plus bx plus c, with a is equal to minus 3, b is equal to 0 and c is equal to minus 3. As you can see here, this is the equation of a parabola. Therefore, the answer A and answer B can't be right because they say that graph is a straight line. Next, you do not have C to be 0, C is not 0. Therefore, the curve does not go through the origin. Therefore, the option is parabola not through the origin. The option is D. Magnetic flux phi b is equal to Ba cos theta. Therefore, magnetic flux can be changed by either changing magnetic field or by changing area or by changing the orientation theta between the magnetic field and the area. We shall see one problem in which we change the area by which we induce EMF in a circuit. Let us move on to the next problem. A circular conducting loop is placed in a uniform magnetic field of 0.04 Tesla with its plane normal to the magnetic field. The radius of the loop starts shrinking at a rate of 2 millimeter per second. The induced EMF in the loop when the radius is 2 centimeters is A 10 microvolt, B 15 microvolt, C 0 volt and D 5 microvolt. Here you are shrinking the radius. If you shrink the radius, the area of the loop goes on decreasing. Therefore, there should be an induced EMF in circuit. We have to calculate the induced EMF in circuit. Magnetic field is given, which is 0.04 Tesla. The radius of the loop is given, that's 2 centimeter, and the rate of shrinking of radius is given, that's 2 millimeter per second, and the angle between the magnetic field and the area is 0 degree because the plane is normal to the magnetic field. Therefore, theta is equal to 0 degree. Let us calculate what is the induced EMF. By Faraday's law, E is equal to minus d phi b divided by dt, which is equal to minus d by dt of b is phi b is b into a. You have a circular loop, therefore area is pi r square into cos theta, that's which is equal to minus b is a constant which is 0.04 Tesla, therefore I can keep it outside, into cos theta, that's 0 degree, therefore that's 1 into, I am left with pi, pi is a constant, I can keep it outside, I am left with d by dt of r square, which is equal to minus b into pi into d by dt of r square is 2r dr by dt. That equals b is given that 0.04 Tesla, I write 4 into 10 power minus 2 for that one, there is a minus sign here, into pi is pi into r is 2 centimeter, that is given 2 into 10 power minus 2 into 2 is here, I write 2 here, into dr by dt is 2 millimeter per second, that is 2 into 10 power minus 3, that is all, 2 millimeter per second, divided by 1 second, I leave that minus. I have to write a minus here because the radius is shrinking, therefore rate of change of radius must be negative, therefore these minuses get cancelled. 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32, 32 into pi is 100. That you have to remember, 3.2 into pi is approximately, very approximately 10, therefore 32 into pi is approximately 100, 100 into 10 power minus 2 minus 2 minus 4 minus 3 10 power minus 7, which is equal to 10 into 10 power minus 6 volt. Therefore, the answer is 10 into 10 power minus 6 volt, which is 10 microvolt. The answer is A 10 microvolt.